address is an int star. If we had a char and we put an ampersand before it, then we would have a char star. So coming down into the swap function, again, this is going to take an int star and an int star. And here, it's unfortunately somewhat confusing that there are two uses for the star. The first use for the star is to declare something as a pointer type. So when you see int star b, you know that b is a pointer to an integer. When you do not see a type, like right here, when you say star a, we are dereferencing that pointer. So if b points to y and a points to x, then star a is referencing the original x. And so temp is going to store the original value of x. Star a equals star b. We're going to go to the original value of x, like the original x, and we're going to store there the original y. And so x has actually been changed now. And here we're doing the same thing. We're going to y and storing the original value of x. Questions? OK. So in Objective-C, a lot of this is going to be, you won't be needing to do as many explicit dereferences, but it's important to remember that when you're passing these things, that objects themselves are pretty much like pointers. And so if you pass an object to a function, and in that function you modify the object, the original object will have been modified. And we're going to see that. And just for fun, I threw in the end that char star star is also an example of a pointer. It just happens to be a pointer that points to a pointer that points to a char. So a good example of that is just our command line arguments, argv. So ignoring the fact that it's bracket syntax, there are some, this isn't entirely true, but in a lot of scenarios, arrays and pointers are pretty much equivalent. So const char star argv bracket, we could have also said as const char star star argv, which makes sense since argv is an array of strings, and we represent a string as a pointer to a single character. Questions? OK, so structs. So it'll be important to actually remember structs because you will still be dealing with them in Objective-C, and a lot of the iOS code will be dealing with some structs. Unfortunately, it can be somewhat confusing because you might forget when you're dealing with a struct versus an object since they are different. But let's look at an example of using a struct. Remember, struct is pure C, and objects are Objective-C. Yes?
Do you have a structure of objects?
So you can, once we get to Objective-C, you can, yes. It's, a struct is literally just a wrapper for a group of variables. So if you can have a variable point to an object, then you can store that variable in a struct just as well. Looking at a struct example that doesn't use objects. We see here this typedef struct student. So the only reason for the typedef is so that, then we technically need to put student here, but the only reason for the typedef is so that whenever we want to declare a variable of this struct type, if we just do this, now we have to say struct student x and struct student y. So the typedef just saves us that. And now we can just say struct student, or now we can just say student x and student y. So what is inside of this struct? We have an age and we have a name. And so these are exactly what structs will look like in Objective-C. And coming down here, we see we declare a variable of this struct type, Alice. And we're going to use dot notation to access the fields in that struct. So Alice.age equals 20, and Alice.name equals Alice. Then we can do the same thing. We just declare Bob. And that's pretty much like everything about structs that you will need. So questions? Oh, and then if you want to look at the greet function, up here we are storing inside of bob.age21, and down here we are accessing bob.age. Okay. Next, we will also have enums, which are somewhat more important in Objective-C than they were in perhaps you've used in regular C, since there's a lot of code you'll be working with uses a lot of enums. So what does an enum look like? So it's like a struct, and again, we're just using typedef so that when we want to declare a variable of this enum type, we don't have to say enum genders x and enum genders y. Thanks to the typedef, we can just say genders x and genders y. So enums aren't strictly necessary. We could instead do hash define female as 0 and hash define male as 1, and hash define just declares this to be a constant. So right now, if I got rid of this, the two programs would be almost equivalent, except for the fact that I just got rid of the genders type. So why do we prefer enums over these hash defines? Because if I add a whole bunch of hash defines, something 2, something 3, something 4, and then I decide to like reorder them, then I would have to like change the numbers on all the rest of them. And also, it's just a convenient way that I don't have to explicitly list the numbers on all these things. Once we get to Objective-C, and I think more specifically Xcode, there's also some, well, it's coming down here. We see that we have changed this struct to now it takes a name and a gender. So Alice is going to be given the name Alice, and is going to be given the gender female. So it's important to remember in C and also Objective-C that there is no enforcement of the gender's type. So I am just as easily able to put 100 underneath the hood, and enum is literally just an integer. So even though 100 is not a valid genders, it will let me do this. But in Xcode, generally it will yell at you like visually if you're using things that aren't correct enum types. So you'll want to use these enums correctly. And that's pretty much it for enums. Questions? Okay. So then arrays. Regular C arrays are still going to work in Objective-C. You're also going to see that there are these new array classes that you're probably going to want to get used to, so you might not be using them that much. Just to look at an example of using the arrays. So here, we declare a variable int n. We print enter number of exams. And then scanf is just a way of grabbing input from the keyboard. So here we are scanfing for some integer. This %d carries over from printf. It's looking for an integer. And why do we need to pass ampersand n and not just n? Why would this never work? Yeah, so inside of the scanf function, just like we saw before with the swap function, ideally, after this point in time, n equals whatever number I typed at the keyboard. So scanf needs to actually change this n. Scanf can't change that without a pointer to that n, without having the address of that n. Otherwise, if I just did this, then, well, first it wouldn't compile. But assuming it did accept that, it would just try to set the local variable n to the keyboard entered value, and this n would remain unchanged. So we need to pass the address. Here we are declaring an array, and that array is going to be of size n, so we're going to have n integers. And this is all going on the stack so far. And then we're iterating over the n values, entering a grade into each individual spot in the array. So really, this program is going to behave like, how many grades do you want to enter? 3. What is the first grade? What is the second grade? What is the third grade? So you enter each grade. And also, we have to pass, so grades I is the ith position in the array. And then we also need to pass that by reference. We need to pass the pointer to grades I